Hello and welcome to our first ever live broadcast. My name is Scott Gainey. I head product marketing here at Palo Alto Networks, and I'm joined by two distinguished guests, Lee Klarich, who's our head of product management, and Nir Zuk, who's our chief technology officer. So we're here in our corporate headquarters. The purpose of today's broadcast is really to introduce you to this box, the PA-7050, which, as you'll see here shortly, is the industry's most powerful next generation firewall. So before we get into that, though, I want to throw out a couple housekeeping items. We have a crowd chat available to everyone here that's tuning into this broadcast, as well as Twitter. So I encourage you all to leverage those resources to submit any questions that you have, submit any comments that you may have. We're going to try at the end of this broadcast to get to all those questions. Knowing that we've got potentially a few thousand people on this broadcast, we've also set up some folks from engineering, from Lee's team, as well as my team. They're in a separate room right now watching to try and answer any questions that you may have that we aren't able to get to here in the studio. So with that aside, we're going to kick it off here really quick. We've got a pretty packed agenda, so we're going to try and capture this all in 30 minutes. Before we get going, I want to pose a first question to Nir, and that's, Nir, obviously you played an integral role in the development, the gestation of this product, right? So you saw a lot of things that were going on in the market. Before we actually get into the details of the 7050, can you walk through just what defines a next generation firewall?
Sure, Scott. A next generation firewall is a device that safely enables applications. And what I mean by that is that there's a lot of focus today in enterprises on protecting email. When an end user receives an email message in an enterprise, that email message goes through a lot of checks, policy checks. Is the recipient okay? Is the sender okay? Is it too big? Is there an executable attachment in it? A lot of malware checks. Is there a virus, spyware, botnet, Trojan, backdoor, and so on? Vulnerability exploits checks, right? Is there a PDF document there that's about to exploit a vulnerability in Adobe Acrobat and take over an end user machine? Recently, we started running email through sandboxing to see whether attachments are bad with something we don't know about. And also on the way out, email goes through all these checks as well as data leakage checks, right? Making sure that intellectual property doesn't leak out. The same more or less applies to web browsing. Now, when it comes to other applications like Office 365, Instant Messenger, Box.net, Salesforce.com, even Facebook, the common thing to all these applications is that they are capable of bringing in and sending out exactly the same information that email can. So the same PDF document that came in via email was about to exploit the vulnerability in Adobe Acrobat and you blocked can come in via Office 365 or Box.net or any of these other applications and nobody's looking at it today. So really you have three options today. The first option is to block the application. The second option is to stick your head in the ground, ignore what I just said, and let the application go through. And the third option you have is to use a next generation firewall from Palo Alto Networks. There's no fourth option.
Yeah. Okay.
So really a next generation firewall takes whatever security you apply to email today and applies it to all applications such that you can use them in a very safe way.
Okay, great. Okay. So I mentioned, we're introducing literally the industry's most powerful next generation firewall. So power is clearly a theme here in performance. Can you talk a little bit about some of the use cases that really drove the impetus behind this device?
Sure, of course. So prior to this, our fastest bulk could have done 20 gigabit per second or so of firewalling, 10 gigabit per second of threat prevention. And what we've seen in the market is a need for multiple tens of gigs throughput in three areas: at the internet connection, in the data center, both corporate data center and external data center, as well as at the core of the network to achieve segmentation.
So really, 10 gigabit we need at the internet connection. Can you talk a little bit about what's fueling that kind of appetite for performance?
Yeah, of course, sounds unbelievable given that 20 years ago it was 56 kilobits per second. But yes, we've seen multiple enterprises, in the educational institutions, governments, and other organizations that already have multiple tens of gigs connecting to the internet to access SaaS applications, internet-based storage, video, audio. Well, audio doesn't need that much. So yeah, we certainly see that.
Okay. So data center you mentioned is a big use case here that we're going after. So obviously this isn't the first chassis-based firewall on the market. So we know a lot of a lot of vendors are talking about existing port-based firewalls as being sufficient for the data center. So why do I need a next-generation firewall for my data center?
My philosophy is that you got to assume that the bad guys are already on your network. So somehow the bad guys made it to a few, maybe more than a few, end-user machines or other devices in your network, and are now trying to break into your data center. So personally, I just don't see a difference between protecting your end users from the internet and protecting your data in the data center from your network, because your network is an extension of the internet, with the bad guys already being on it. So to protect your data center from your network, you need to see which applications are being used, how they're being used, what kind of content is running back and forth. All the things that next generation firewalls do and port-based firewalls don't.
Okay. And then you mentioned another use case in terms of network segmentation. So sitting between those two, network segmentation isn't necessarily a new concept, right? It's something that I think many have been talking about for years. But can you talk about maybe in the context of some of the latest breaches, right? Why is this suddenly percolating to the top is critically important for CIOs? Yeah,
I think that what we've seen with the latest breaches, especially in the retail world, but in other areas as well, is that the bad guys take over an end user machine, and then from there they jump around the network, from one machine to another. And today, with the VLAN-based segmentation of the network, we just can't stop it, because traffic should flow between different segments. It's just that you need to look into the traffic and make sure that it's the right traffic. So there needs to be application-level inspection at the core of the network. And the other issue, of course, is that users don't have IP addresses anymore, and users don't sit on a specific VLAN once they roam around the enterprise. So your segmentation needs to be user-based and not IP address or VLAN-based.
Okay, good. Well, thank you for the backdrop, definitely. So I think, Lee, we're going to kick it over to you now. We've got a PA-7050 sitting between us.
Yes.
So walk us through. What are we looking at here?
All right. So this is, for us, this is a major accomplishment to come out with a platform this powerful, quite honestly. And 9U, height-wise, 8 slots, the most powerful next-gen firewall. Just a quick physical walk through the platform. What you see here in these 6 cards, these are the network processing cards.
Okay.
This is where really all the magic happens for the most part. This is I/O, processing, security, and you start with 1 and you can ramp up to 6 based on I/O capacity needs, performance needs. There's then 2 special cards here. One sits right in the middle. This is the switch management card. This is where first packet processing happens, which I'll explain a little bit later, but it's basically session distribution and management plane. Okay. So high speed, 4-core, Intel processor, lots of memory, SSD, things like that. And the last blade, which is a dedicated log processor. Okay. Dedicated storage, multiple processors for compression, decompression of logs, so very high speed storage and retrieval of logs for all the reporting and visibility things that we do.
Okay.
So, and of course power and fans and all that kind of stuff. Hot swappable cards, fans, power supplies, obviously very data center friendly from that perspective.
So, you go through the various data sheets, right? There's a lot of data sheets out there that talk, very high throughput at the top end, right? And so, what makes this the fastest next generation firewall?
Well, lots of things, really. I mean, I think a lot of it starts with PAN-OS, which is the operating system that runs on all of our platforms. A single pass architecture for scanning content level traffic is actually one of the fortes that we've developed and perfected over the last many years across the different platforms, and those same capabilities apply to this platform as well. In fact, it runs the latest version of PAN-OS released last month, 6.0. So a lot of what makes it the fastest is actually in the software that we've been working on for many years. Then from a hardware perspective, of course, that's what makes it the fastest within our product lineup.
Okay.
And so part of it is simply being a chassis with the ability to scale out linear scalability of network processing cards for additional processing power and I/O. And the other part is when you look at the actual architecture of what each of those blades looks like and what they can do, you start to see the rest of what makes it the fastest.
Okay. I know we've got some performance numbers that we wanted to throw up, as well as I think we've got a picture of the architecture itself. You want to take us through that a little bit?
Yeah, so if you throw up the first slide, guys. Let me just walk through this real quick. So the first piece to look at is sort of at the bottom of this picture is all of the network processing. So this is per packet routing, flow lookups, sort of lower level networking stuff done at very, very, very high speeds. Okay. And then sitting behind that is a security processing layer. So on each of the NPCs, there's quad Cavium chips with 32 cores each, so a total of 64 CPU cores per blade, lots of dedicated memory and things like that. And then sitting behind that is the security processors, which are hardware-based signature lookup engines, basically. Okay. So that's a single NPC. And then you multiply that by 6, and you basically reach more than 400 CPU cores per PA7050. And that's where all of the security processing and things like that happens. Behind that, of course, is the switch management card. That's all the things that have to be done in terms of managing configuration, entire system. The first packet processors, where we do session distribution across cards. And the last piece is the log processor, being able to offload that to dedicated hardware so that you're not consuming shared resources, but rather having dedicated resources. Okay. So that's the architecture behind this that allows it to scale. And then if you move to the next slide, guys, what that results from a performance perspective is truly amazing. So when you turn everything on, app ID, threat prevention, URL filtering, wildfire behavior file analysis, IPS scanning, all of that, this box can do 60 gigabits per second of throughput, measured with HTTP 64K transaction sizes, which is a very sort of normal type of traffic. Okay. Not inflated numbers using UDP and stupid stuff like that. And that's performance with everything turned on. Yeah. If you wanted to use this for firewall with app ID and user ID, then you actually can get up to 120 gigabits per second of throughput. Okay. So it's a combination of those numbers, definitely, that backs the fact that this is truly the fastest next generation firewall in the industry. Yeah. Yes, absolutely. Good. So before I've got some questions, I want to flip it back to Nir here in a second, but before we do that, I think you touched on some of the specs. Is there anything else you want to call out? I think we've got some details in a table. Yeah, why don't we put that up, guys? So obviously there's a full spec sheet available on our website, and I encourage you to go there to get all of the details, but these are some of the highlights that I think are sort of important. So the raw performance, 120 gig total, basically 20 gig per blade. DSRI is basically a mode for where you're just protecting servers. You're not looking at response traffic, so it's pretty close to 120 gig as well. And then when you turn everything on, as we just talked about, it's 60 gig for the chassis, 10 gig per card. A few other specs that are meaningful. In total, can support up to 24 million concurrent sessions. About 720,000 connections per second can be set up, which is beyond what probably just about any network requires, which is, of course, always nice to have headroom. And you see some of the other metrics as well. The key thing, though, is just across all capacity and performance metrics, it's a beast from a performance perspective. Great. Okay, so before I'm going to give you a second just to kind of collect some ideas, but one of the things I'm going to throw your way, Nir, is I think Lee talked about some of the uniqueness, certainly at PA7050. This isn't the first chassis-based firewall on the market, so I'm going to give you a couple seconds to think about it, but I'd like you to address kind of what truly makes this unique in the market, relative to some of the other offerings. Just as a quick pause, for those of you tuning in, please just want to make sure that you're leveraging our chat capabilities. Get in your comments and questions. We're going to open it up for questions here probably in the next 5 or so minutes. And then also there is a feature too. If you're interested in what you see, you want to schedule a private introduction with somebody from Palo Alto Networks too. There is an ability to fill in your name, your contact information on the broadcast website, so we can make sure that we contact you after this cast. So with that housekeeping out of the way, Nir, I want to turn it to you. So not the only chassis-based firewall on the market. How does this compare against some of the offerings that the folks on this call have access to?
Sure. I think first it's a next generation firewall. You know, I described earlier what the next generation firewall is, which is something that enables the safe use of applications. Our competitors agree with us on the problem, which is that all these different applications carry risks. Where we disagree with our competitors, specifically our firewall competitors and our threat prevention competitors and sandboxing competitors, is on the solution. Where their solution is, here is a UTM module or a blade that can block these applications. Our solution is, no, don't block them. Use them, just secure them the same way you secure email. So our competitors don't have a slow next generation firewall, and they certainly don't have a fast next generation firewall, and that's probably the biggest difference between us and our competitors. Specifically, if you look at throughput, and this will be an apple and oranges comparison because this is a next generation firewall versus a traditional port blocking firewall. If you just look at our competitors running firewall plus IPS, or IPS and maybe application blocking, we are way faster than them. Where some of our competitors, I mean, for example, specifically Checkpoint, which has a chassis called the 61000, fully loaded. I think it's a 12 blades or something like that, as compared to these 8. That chassis is advertised as a 400 gigabit UDP firewall, because UDP is the only traffic on the internet, of course. But when you start turning things on, according to Checkpoint, if you look at their data sheet, if you turn on the IPS and you turn on application blocking, you lose about 85% of the throughput just there. Whereas, as you heard here, our performance stays constant no matter what you turn on. And more than that, last week I met a customer, a very big bank, international bank, and they actually tested a fully loaded 61000. And they told me that when they turned on anti-malware, which is not something that's on the data sheet, they only got 400 megabits per second on a advertised 400 gigabit firewall. So 99.9% reduction in performance. And the same is true for the other competitors. If you look at the Juniper SRX platform, it's the fully loaded one, the 58000, is about 200 gigabit firewall. According to their data sheet, if you turn on just the IPS and their application blocking, you go down again around 85%. Wow. And you still don't have a next generation firewall, and you still don't have anti-malware, sandboxing, and all these other technologies in that number.
Okay, good. Lee, open it up. And if there's anything else, put you on the spot, but if there's anything else you'd like to add before we turn to some of the questions that are coming in.
Yeah, I think, excuse me, I think one of the other things that gets lost in a lot of this is there's a right way to build a chassis and there's a wrong way to build a chassis. And in a lot of cases, security companies aren't particularly good at building chassis. They simply don't have the expertise. And you see it in some really strange things as we've been looking at some of the other platforms out there, where there's some of these where every time you want to install a new blade, they require that you buy professional services, and somebody from that company has to come install the blade for you.
Yeah. Because
it's so complicated that you can't do it yourself. There's others where each blade actually has its own configuration, its own management, and is basically disjoint from the rest of the platform, in which case basically what you have is one big piece of sheet metal with lots of separate devices plugged into it, which doesn't solve any problem. And then there's others where every time you want to add a blade, they'll charge you for support and subscriptions for each blade independently. So every time you add a new blade, you're adding a whole bunch of other costs with it.
How is that different here?
Well, we basically didn't do any of those things. We start by building a platform where it, from a management perspective, it operates as a single device. You manage one of these, period. You want to plug an additional card in, all the processing power added is automatically available without changing anything in the configuration. It's just automatically available as additional processing power. Whether you use the I/O ports or not, it's all linked together through the switch fabric.
But what about licensing? You mentioned licensing.
Per chassis.
Per chassis, okay.
Per chassis. So you buy support and subscriptions for the chassis, and then it doesn't matter how many of the processing cards that you add, they're all included in that.
Provides a very predictable operating model for our customers, right?
Completely.
Okay.
Absolutely.
Good. All right, well, we do have some questions coming in. So the first one, Lee, I think is directed towards you. I think we've talked about, Nir talked about some of the use cases, right, relative to internet gateway, network segmentation, data center. You talked to hundreds of customers, right, leading up to the release of this product. And by the way, it is available today, and so we're already taking orders in. Can you add any more color? What are some specific use cases that you're seeing with a few of these early accounts?
I mean, it's what Nir said. I mean, we really truly see a lot of organizations across enterprise, government, education, financial services where they simply have 10 gig, 20 gig plus connections to internet. And so simply being able to apply all the same security capabilities we have, but to these larger environments is great. On the data center side, we actually sell probably somewhere between 35–40% of our business is into the data center already. But as Nir said, the performance requirements are rapidly expanding. Data center consolidation is driving that, increasing amount of business connectivity into the data center and having to be able to apply the same protections to all your business partners that are connected. Virtualization is driving a lot of that in terms of being able to protect highly scaled out virtualized data centers. And to Nir's point, the internal segmentation, the zero trust architectures are really, 2 years ago, I don't think I heard a single enterprise talking about zero trust architectures. And today it probably comes up, at least 25% of conversations I have is, how do I provide internal segmentation? Not like separating networks, but allowing them to connect in a secure way and only allowing trusted connections and things like that.
Great. Okay, so another question. We'll make this a toss-up between the two of you in terms of who wants to address it. But let's see, historically, firewalls have been tested with UDP. So clarify, where is UDP testing useful, right?
Yeah, UDP.
And where is it not?
So UDP testing is useful for marketing departments of our competitors because that's how they can say they use that. There isn't a lot of UDP traffic on the internet. Most UDP traffic is DNS. The majority of the traffic will be UDP if you're a DNS provider. Many of them are our customers, by the way, so even that use case is not relevant for old port blocking technology. UDP testing is completely irrelevant. It's just a way to inflate numbers. Even TCP testing has to be done at the connection level, meaning not just throwing TCP packets at the device, but creating real connections with real data in it. Like Lee said, real transactions. We tested using 64K transactions, which are pretty typical on today's internet. And you have to do it with everything that you want to use turned on.
Okay.
Yeah, just to follow on that, I think, so on the UDP comment, Skype and peer-to-peer applications use UDP. So if your goal is to have a highly infected network with lots of content that's been stolen and counterfeit, then you probably care about UDP performance.
Okay.
But real business applications simply don't. On the TCP side, just to drive the point home, when we do the testing, we take HTTP traffic with a real transaction. In that transaction is all of the connections set up and actual content in the payload being delivered, and that's what we call the transaction size. The net result of that is a mix of packet sizes from small packets to big packets. So you naturally get an iMix, if you will, an internet mix. And that is absolutely not the same as when you see TCP packet sizes of blank, because what they're really doing is there's no content, there's no payload, it's not a real application.
Okay, good. One other housekeeping item I have to throw out there, and that's you will have a chance if you would like to come see it, feel it, touch it. We've got our Ignite User Conference. It's coming up at the end of March. We expect to have over 2,000 attendees there. We'll have 55 different technical sessions. We've got hands-on labs where you can come, have a chance to really crack the UI, set it up, just play around with the box as well as meet folks like Lee and Nir there. So just want to make sure that you guys all have that on your calendar as well. So with that, I don't know if there's any other any big topics that you guys want to try and cover that you don't feel. Nir, any other color commentary on terms of what are you seeing from a customer perspective, customer interest out there in the market relative to these high-end enterprise next-gen firewalls?
Yeah, I think that we're seeing the architecture for network security changing, where more and more customers are viewing their network security device, the inline device, as a device that does three things. Number one, it understands the traffic and controls it. Is it okay? Is it not okay? Applying policy to the traffic. Number two is applying all kinds of signatures to the traffic. Traffic signatures for command and control, download signatures to look for downloaded bad documents or executables being downloaded, DNS signatures to look for DNS traffic from your network trying to resolve domains that are known to be bad. URL signatures to make sure that you don't go to bad URLs or you don't go to URLs where the content is deemed inappropriate. So applying a lot of different signatures to the traffic at extremely high speed, low latency. And then the third thing that we see those inline devices do is collect information from the network, collect files, collect URLs, collect DNS traffic and other information, send it to a cloud, either a private cloud or our cloud for processing, quickly determine that there are new attacks in the traffic, running them in sandboxes, looking at DNS traffic, looking at the kind of URLs that people are going to, immediately generating signatures, all these different signatures I talked about, and distributing them to all the high-speed, low-latency internet devices.
Great. Yeah, I'm glad you touched on that. I think we'd be remiss certainly if we didn't talk about the complete ecosystem around the PA-7050, right? In order to safely enable applications, prevent all those known threats that exist out there, as well as detect the unknown threat. So,
correct.
Lee, any parting comments that you want to leave before we close the broadcast?
No, I think we covered it.
Okay. Actually, before we, thought we did. So a few more questions streaming in. Okay. This one comes from Twitter Sphere. So certainly FireEye's garnered a lot of attention in the press as of the last few days. Some questions with regards to PanOS and how does PanOS compete against some of what we're hearing from FireEye, specifically relative to this IPS offering that they're talking about.
Sure. So first I would like to welcome FireEye to the Prevention Club. For the last several years, FireEye has been pitching, you just need to detect.
Yeah.
And now I think FireEye is realizing that it has to be part of a bigger ecosystem where you don't just detect bad things, you also block them. I think that an IPS is a good start, meaning you have to block the command and control connections. So you receive a malware, you find a malware in your sandbox, you run it, you see the command and control connection that it generates. You want to take that command and control connection and stop it in your IPS such that if it's already on the network, you can block it. But that's just a start. You need to look at the traffic coming in and scan for malware. You need to look at DNS traffic. You need to perform content filtering and look at the URLs such that you don't allow your users to go to URLs that are known to be hosting malware or command and control servers. And you want to do all of that at extremely high speeds, at 60 gigabit per second in the data center. Now, digging into the FireEye solution, which is, by the way, not available yet, it's going to be available, I understand, towards the middle of the year. Number one, we think that because it's running on the existing platform, which can't even do a gigabit, it's not going to be more than a gigabit IPS. Not sure what the data center story there is or the fast internet connection. And second, it seems to be based on snort. And my take is if you want to use a snort-based IPS, you might just go to the real thing and buy it from Cisco instead of buying a stripped-down version from FireEye.
Okay. So, question for you, Lee. Lot of talk about virtualization. You mentioned, certainly one of the core use cases driving the need for throughput and performance of this level is data centers consolidating use of virtualization. But what else are we doing to address this movement into highly virtualized, highly automated data centers?
Yeah, I think it's a great question. Probably 100% of enterprises I talk to, when they talk about data centers, they've virtualized their servers. And what that basically means is they have to buy fewer servers, they get better utilization, and that's a good thing. In many cases, they save massive amounts of money doing that. But what none of them actually do is really leverage the power of virtualization for enabling the dynamic and automated capabilities that virtualization really allows them to do. When you think about it, with virtualization, you could spin up a new virtual machine, a new server, in seconds. Traditionally, though, security policy would, in a typical workflow for creating a new security policy, would take weeks to create it, get it approved, change control window, commit the new policy, and so you have this massive difference of how quickly you can change the infrastructure and versus how fast your security policy can secure it. And so what we've done with the 6.0 releases, and we had an earlier version of this with 5.0 over a year ago, is we can actually create context for the virtual machines and then use context in the policy. So instead of setting policy by static attributes of a virtual machine, like an IP address, we set it based on the properties of that virtual machine, tied in through VMware's NSX and other monitoring tools. We can create policy once, and then have that policy dynamically applied to all virtual machines that look like the ones that we already know about. And that applies to our virtual platforms, the VM series, but it also applies to all of the hardware appliances like the PA7050 as well.
Good. Yeah, what it means, you can have a 7050 in front of the data center, usually you'll have two of them, running at 60 gigabit per second, looking at all the traffic, and coordinating with the orchestration tool to understand all the dynamic changes in the data center and automatically adapt to them.
Okay. Good. Well, I know we're at time. I'm going to try and squeeze in one more question here, if we can. So, Lee, you touched a little bit on the licensing, right? There's a question about, first of all, does it support HA? And then talk a little bit about load balancing. I think you talked about how as you add in NPCs, right, that performance is automatically recognized. But if you can talk just a little bit about how that performance is balanced across the 7050.
Sure. So yes, it supports HA, active, passive, active, whatever you want to configure.
Yeah.
So the load balancing I was talking about, so just to be clear, we're not talking about server load balancing. We're talking about basically load distribution across the different NPC cards. So when I mentioned briefly the notion of a first packet processor for distribution of sessions. So when a packet comes in, regardless of which NPC it comes in on, that session can be processed by any of the NPCs that are configured. And the way in which the sessions are distributed actually is configurable. So for example, in a high frequency trading environment where you want latency to be as low as possible, you can actually force the session to be handled by the card that it came in on, so that it touches as few components as possible. Mm-hmm. And we're talking about microseconds of latency, by the way. So it's, for a normal environment, it doesn't really matter, but in those environments, a microsecond matters a lot. Or more likely, you simply distribute based on available processing, available sessions, and things like that. And so all of that is done dynamically, unless you specifically want to change the configuration of how the distribution happens.
Good, great. Okay, so we're going to wrap it up there. For those of you who tune in, I appreciate the time. Definitely, this session is also recorded. We're going to be posting it up on the web shortly. So if you want to rewatch it, if you want to catch some of the details that we crammed into the last 30 minutes, you'll have that opportunity. Or obviously, if you want to distribute it to other folks within your organization, just to share the information, you're welcome to do that as well. As I mentioned, if you want to schedule an appointment to actually have more of a one-on-one discussion about the PA7050, happy to do that as well. There's a function on the website for you to submit your contact information, and we'll follow up with you immediately. So with that, we're going to close out the session. I appreciate the time, and look forward to meeting you all, hopefully at Ignite.
It's been awesome. The speakers have been great.
A lot of humor that I wasn't expecting in some of the early presentations.
The Expert Lab has been absolutely excellent. It's really made me think.
Just one-on-one with them, answering questions, getting insight.
Join with other users, discuss with other users what other people are doing.
Very informative, learned a lot of stuff, have a lot of ideas going forward to help secure our network.